To determine the end behavior of polynomials, keep in mind these two graphs. First, the graph of y equals x squared. Starts high, ends high, high on both ends. So the end behavior is that it's at positive infinity on the left and also positive infinity on the right. But if it's multiplied by a negative number, then it got flipped vertically. And now the end behavior is opposite. Negative infinity on the left and negative infinity on the right. The second graph you should keep in mind is y equals x cubed. It goes from low to high. So the end behavior is that it's negative infinity on the left and positive infinity on the right. And if it's multiplied by negative, then again it got flipped vertically and the end behavior goes opposite. Positive infinity on the left and negative infinity on the right. So keep those two graphs in mind. Part 2 coming up next. End behavior, part 2. Keeping in mind the graphs of x squared and x cubed, the general idea is this. An even degree polynomial will behave like x squared and an odd degree polynomial will behave like x cubed, as long as the leading coefficient is positive. This graph, even degree, positive leading coefficient. It behaves like x squared, high on both ends. Positive infinity on the left, positive infinity on the right. But now this graph is even degree but negative leading coefficient, so it got flipped upside down and now it's low on both ends. Negative infinity on the left and negative infinity on the right as well. So the idea is even degree polynomials behave like x squared, except that if the leading coefficient is negative, then it got flipped around and points down on both ends. Next, part 3, I'll talk about odd degree polynomials. End behavior, part 3. Quick reminder, the graph of x cubed goes from low to high, negative infinity on the left, positive infinity on the right. And the idea is odd degree polynomials will behave like x cubed when the leading coefficient is positive. Like this one, degree 7 is odd and the leading coefficient 2 is positive, so it behaves like x cubed. It goes from low to high, negative infinity on the left, positive infinity on the right. But this one is odd degree, but the leading coefficient is negative 2, which is negative, so it behaves like an x cubed that has been flipped vertically. So it starts high, goes low, positive infinity on the left and negative infinity on the right. So if you just remember these two graphs and remember that negative coefficient will flip it upside down vertically, then you can figure out the end behavior of all polynomials.